Welcome back, Algebros. I hope your first adventure into the factor forest wasn't that bad. Let's talk about the next part of it right now. We've learned about pulling out GCFs of variable terms, but another important thing when it comes to writing out factored forms for quadratic expressions is being able to divide a variable term by another. Obviously, you've done tons of long division in your time from elementary and middle school. But how do we do something like we see right here, where it's 3x squared divided by x? How does that work? How do I divide x by x when I don't know what x is? Don't fret. It's fairly simple. Kind of like how before when we talked about GCFs, we'd use the numbers by themselves and the variables by themselves. This is another situation that's like that. We first divide the numbers, which we know how to do. The thing we may not know is what happens with the variables. We do the top exponent minus the bottom for each variable. And that's fairly simple. And finally, slap them together. That slap together is through multiplication. So, how does that look? In the most basic situation, once again, much like how we saw the GCF of x squared and x, this is another one that is probably algebra fairy related, because, honestly, you're going to see it so much that it's going to become second nature. X squared divided by x. The numbers, remember, the coefficients are just 1, so it's 1 divided by 1, which is just 1. The variables now, it's going to be 2 minus 1 from the exponents. 2 minus 1 is just 1. So the variable now is going to be just x with an exponent of 1. Fairly important fact. That's why there's an algebra fairy and a circle around it. Keep this one in mind. Conversely, if you have a situation like this one, let's follow. We have numbers and variables. So I'm going to start off with the numbers. 4 divided by 2, easy, that's just 2. Now the variables. It is now x divided by x. If we follow the rule of subtract the top exponent from the bottom, or bottom from the top, I should say, it's going to be 1 minus 1, which is 0. And if you remember the fact we saw before, that any number with an exponent of 0 is just 1, we realize it's just 1, and we don't have to put anything. Another way of kind of thinking about this is almost as if x and x will just cancel. Meanwhile, on this other one, the x with just the squared will cancel. But if that's too hard, you can completely forget that I said that. And that's just a big old dum-dum from me. Now we got a bunch of samples. Let's try a couple of them together, and then I leave the rest for you as an exercise. So, 7x squared divided by 7x. First up, we look at the numbers. 7 divided by 7 is just 1. Then we look at the variables. X squared divided by x. We have a fact for that. X squared divided by x is just going to be x. So our answer here, 1x. Now, next one, 15x divided by 5x. 15 divided by 5 is easy. That's just 3. And then x divided by x, we have another fact for that up here. If we had x over x, it just cancels itself out. Boom, boom. Our answer to the division, our quotient, is just 3. Next up, 12x divided by 6. Note over here, we don't have a variable on the bottom. So is there anything to divide? No. The x is just gonna stay there, untouched. Meanwhile, 12 divided by 6 is easy. It is just 2. Nice and simple. It's just a matter of memorizing a couple of facts along the way, which is why I think I can trust you guys to work with these as you tries. Long division sucks, but I think this is way easier. I think you'll like it more than long division. I can't wait to see how you feel in class very soon.